Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So hello students, we'll be talking about the components now. As we've already seen the introduction and the working of the pumps, now let's move on to the main topic, that is components. It's because it's very important to know the component to understand the machine, to understand the efficiencies. You should know the components first and their constructional details. So we'll be talking about the components in this lecture. So the main components of centrifugal pump, let me list them down first and then we'll look at them individually. So these are the five main components of centrifugal pump. First is the impeller, second is the casing, third is the suction pipe, fourth is the delivery pipe, and next is the foot valve with strainer. So before going on to each of the components, let me draw the whole centrifugal pump so that will come to know where the casing is, where the impeller is, where the suction pipe is, where the delivery pipe is, where the foot valve is. So before going on to individual components, let's see the whole picture first. So this is how a centrifugal pump looks like. So as you can see, there is a suction tank where the water has to be sucked from there, and you can see the delivery tank. I forgot to name them. So this is how a centrifugal pump looks like. So as you can see here, there is suction pipe, then there is casing, then you have a delivery pipe, then there is delivery tank, there is suction tank. This thing that you can see here is strainer, because water contains impurities, so the impurity should not enter into the pump. Hence we have installed a strainer. Hence we have kept a strainer so that the things get strained out, the mud and everything gets accumulated in the strainer, and the water that goes up should be clean. So once the water goes up, the impeller starts rotating. The impeller is mounted on a shaft. The shaft is coupled to a motor. So the motor generates RPM and the impeller starts rotating. So this rotation creates pressure difference, and because of pressure difference, the water gets sucked in. The water gets sucked up and it enters into the casing. And after it enters into the casing, it strikes the impeller, and an impeller gives kinetic energy to the water particles. The water particles, again in turn, because centrifugal forces start moving at the outlet side, and they come out from this side, and with very high pressure energy, they go onto the delivery tank. So this is how it works. The whole principle works. So now this is the whole diagram for centrifugal pump. Now what we'll do is we'll see each of the components in detail. We'll see impeller in detail, we'll see casing in detail. So we'll see what suction pipe is, what delivery pipe is, and there are different terms also involved with centrifugal pumps, like priming, then cavitation. So we'll see all those terms as well. So now let's look at individually each of them. So we've seen the centrifugal pump as a whole, the whole diagram we have seen. Let's now move on to individual parts. So the first topic that we'll be taking is in types of impellers. We've seen what impeller is. Now we'll be discussing in detail about the impeller. So let me tell you first of all what impeller is. Impeller is nothing but the rotating part of the centrifugal pump. The part that rotates, we call it as impeller, and the impeller is like a disc, or you can say it's having the vanes mounted on a certain disc. So these vanes mounted on a disc is mounted on a shaft. So these impeller is mounted on the shaft, and the shaft is run by a motor. So indirectly the impeller has rotational motion, and this rotational motion of the impeller, which helps water to be sucked up because of difference in pressure. So now, depending on the type of impeller, depending on the type of fluid that is being pumped, there are different types of impeller. So let me list them down. So the first is closed type impeller. So in closed type impeller, what you have is there are backward curved vanes, and vanes, along with the vanes you have two plates on both the sides. So closed type impeller is vanes along with plates on both the sides. So there is a vane at the center and you have plates on both sides. So closed type impeller is used for generally fluids that are very clean, fluids that are having full purity. There's no outside mud involved or anything, any waste involved in. So these pumps, these impellers are used for fluids which are very clean, which are without any impurities in it. So like example, if you're pumping a pure water, you can use a closed type impeller. That is impeller which is having vanes along with plates or disc on both the sides. So that is the case when you use closed type impeller. Next is semi-closed. Semi-closed impellers are the impellers in which you have vanes and plates on only one side. So only one side plate and you have vanes. So you can call it a semi-closed impeller, and it finds application in fields like, suppose a liquid is having certain amount of mud or certain amount of impurity in it. So you can use a semi-closed impeller. Next is the open impeller, open type impeller. Open type impeller are used for fluids which have a lot of dirt, which have a lot of mud. So the concept behind creating different types of impellers is, see, in closed type impeller, the water, that is a pure water or a pure liquid, has a proper way, has a proper guide way through which it goes. Whereas in case of open type, there is no proper guideway because there is no proper liquid. There's mud, there is a lot of dust, there is a lot of mud involved in it. So there is no proper way the water can go through. So you use open type. So if there are impurities are less, so you go for semi-closed. So depending upon the purity of the liquid, we decide what type of impeller to use. So closed type impellers are used for very pure liquids. Second is the semi-closed type impellers. They are used for liquids which are carrying a little bit of mud. Third is the open type impeller. They are used which for fluids which have a lot of dirt in it, which have a lot of mud. So it is just a guideway or a pathway which these impellers decide through which the liquid passes. So depending on the application, you have different types of impellers. So that was all about the impellers. Now we'll move on to different types of casings. So we have three types of casings. First is volute casing, third is the vortex casing, and third is the casing with guide blades. So first we'll discuss about volute casing, and we'll draw the diagram for volute casing as well. Then we'll move on to vortex, and then we'll move on to guide blades. So let me draw the diagram for volute casing first. So what happens here in case of volute casing, as you can see, the cross section area goes on increasing. See, as you can see here, the cross section area goes on increasing. So the moment the water enters into the impeller, it gets inside the pump, it has very high velocity because of its pressure difference. It has very high velocity. Now, as it moves along the periphery of the casing, this velocity, because of increasing area, the velocity goes on decreasing. Since the area is increasing, velocity has to decrease. So the velocity is decreased, and this velocity is converted to pressure. And what you obtain at the outlet side is a very high pressure. So volute casings are designed in such a way that the cross section area goes on increasing, the velocity goes on decreasing, and which in turn helps the water to gain more pressure energy, and this pressure energy helps the water to move further ahead, further up and to the delivery pipe. So this is how volute casing looks like. Now we'll move on to the next type of casing, that is the vortex. So the next type of casing is a vortex casing. You've seen what is a volute casing. Next is vortex casing. So we were talking about vortex casings. We've seen volute casing. Vortex casing are a bit different. The construction is almost simple. There's one more extra thing, that is vortex chamber, that is involved here. So when the water is moving along the periphery of the impeller, after coming out of the impeller, it goes onto the vortex chamber. And what this vortex chamber does is it absorbs all the eddies. It reduces the eddies. That is the rotations. That is the rotation of the fluid. And these, because of the reduction in eddies, the losses that happens because of eddy creation is reduced, and in turn the efficiency of the pump increases. So vortex chamber helps to reduce the losses that happen in the pump because of eddies, that is the rotations of fluid. So that it avoids vortex chamber, and in turn it helps to increase the efficiency of the pump. So this is a vortex casing in which you have a vortex chamber. Similar to volute, there is one more extra term involved, vortex chamber. So the different name, vortex casing. Now we'll see the third type of casing. So casing with guide blades, you will see. So there's an impeller, and after the water comes out of the impeller, it has to glide over one more extra part in this case, and that is called as the guide blades, or you can call it as the diffuser. So what it does is it helps to increase the pressure of the fluid that is coming out of the impeller. The water that is coming out of the impeller already has a very high velocity. Now, what this the guide blade or stationary diffuser does is it helps to it's kind of a diffuser. So what it does is it increases the pressure at the expense of velocity. So the velocity increases. I mean the pressure increases and the velocity goes on decreasing. And with such a high velocity, the water can very easily move upward. So this is just an advanced version of the two that we saw earlier. So guide casing with guide blades. So we are done with the casings, we are done with the different types of impellers. Now let's see what are suction pipe and delivery pipes. So suction pipe is a pipe which connects the suction tank to the input of the pump, to the inlet of the pump, you can say. So suction pipe is a pipe which connects the input, which connects the suction tank with the input of the pump. Next is the delivery pipe. Delivery pipe, what it does, it's just a connection between the outlet of the pump and the delivery tank. So let me write it down. So delivery pump connects the outlet of the pump with the delivery tank. So the definition is very simple. There's no types in suction pipe. They're just a pipe. They're just a connection with the tanks and the pump. So these two pipes, they just help to connect the pump with the tank. Next is the foot valve in the strainer. So we've seen what is different types of impellers, different types of casings. We saw suction pipe, delivery pipe. Now let's talk about foot valve and strainer. So foot valve is the valve which allows water to flow only in the upward direction. So when the water moves from the tank into the impeller, it has to go upward. So the valve opens only when the water moves upward. So the water cannot flow in the reverse direction. It cannot go down. So foot valves take care of that. Strainer is just to strain out all the impurities that is present in the water. So that is the work of foot valve and strainer. Foot valve is a kind of a non-return valve, and strainer is just for cleaning purpose, for cleaning the water. Now there are few more attachments on the pipe. If you observe a central pump, and you see there is a vacuum pressure gauge on the suction side, and there is a pressure gauge and the delivery side, because when the water flows from the suction side, you should see to it that the pressure is not following, it is not falling below the atmospheric pressure, because if the pressure falls below the atmospheric pressure, there are chances of cavitation, and at the pressure on the delivery side has to be measured, because you should know what pressure the water has, so that it can does water have energy to move in the upward direction or not. So knowing the pressure at both the sides, inlet and outlet side, you'll come to know the working of the pump. And there are also certain walls, there are certain funnels attached to the central pump just for priming purposes. So priming we'll see in the next lecture. So there is one valve opening, there is one opening through which you insert water into the pump, so that the pump gets full of water, and that procedure is called priming. So there are certain openings, there are certain valves on it, and there are certain pressure gauges. There is a non-return valve at the delivery side and the suction side, and there is a valve at the delivery side as well. So these all these components, they all together make the centrifugal pump. So each of them we saw in detail. We saw casing, and there are different types of casing. We saw impeller, there are different types of impellers. Then we saw suction pipe, we saw delivery pipe. Then we saw what is a foot valve and the strainer. Then we saw that there are different pressure gauges on the suction side and delivery side, and the importance of priming and the openings that we have on the pump. So that was all about this topic, different components of centrifugal pump. So I hope you've understood. Next we'll move on to, in the next lecture, we'll see the mathematical part of the central pump, the velocity triangles and the efficiencies. So I hope you have understood this lecture. Thank you.